Hello, my name is Alex, and this is my development log for Pythagoras's polygonal numbers. I wanted to start this by just giving a brief overview of all of the files that exist now at the end of the project. I'll start by going through my notes. This is the first thing I drew. I knew I wanted to do something with Pythagorean proofs, which I learned involve rearranging dots. I thought that was a pretty interesting way to prove things, and one that might work well as a game. So I drew this up to demonstrate a couple of things you might be able to do by rearranging dots. This was my idea for what the game would look like. You'd have levels. Originally I thought 15, ended up just being 10. And you would have done levels, locked levels, and the newest level. This was my idea for the game loop. You start at the title screen, you go to level select, you go into a level, you get a short explanation of what you need to do, you solve a puzzle. Turned out lose doesn't go back to level select, you just get to keep playing. You get another little short bit of dialogue, you go back to level select, and now a new level is unlocked. This pretty much stayed the same except for this bit right here. These were my original drawings of Pythagoras before I got Janelle to help me with the art. This was just me planning out the dimensions of things. So use the canvas for buttons, which I actually didn't end up doing for level select. I did use it for the title screen and also for the dialogue system, but not actually for the level select, which is interesting. This is just me planning out levels. I just drew them out on paper. As you can see, I used the same piece of paper for this one. So that's it in terms of handwritten notes. As you can see, this game was originally called My Life as a Teenage Pythagorean. And let me show you guys the programmer art. Some of this is still in the game, but this is all the art that I made. Just the bare minimum stuff that I needed so I could start programming. This, of course, transitioned into this finalized art. Some of it by me. This, of course, transitioned into finalized art. Some of it by me, and some of it by Janelle. I think it's pretty obvious which ones are Janelle and which ones are me. But yeah, some of it didn't get used, like this animation and like this revised version of Pythagoras. Here's all of the files, the GIMP files that I used. I used GIMP as my Photoshop alternative. And here's all of the sounds. Most of these I recorded. Wrong.og is derived from something I found on freesound.org. And this music here is some free use Greek music that I found. Very happy with this music. So yeah, that's all of the files that I have here. Let's jump into the final Unity project. So this is what it looks like. I have a game handler, which has a lot of the core of the game, which has a dot handler script, which handles the moving of dots with your mouse or finger. I have a level handler, which determines the state and does state switching. I've got this level select screen here, which has 10 level select buttons, which are all prefabs. So I just went in and changed the level ID here, and they all have the same playable, locked, and completed sprites that we saw earlier. And they all have a reference to the game handler. And then these are just pillars, decorative. There's this submit button, gets to be its own object, as well as the goal box. And the goal box is just an image that changes depending on what level you're in. And the submit button just becomes active and calls a function called CheckAnswer, which whatever the answer for the level is, it'll compare your arrangement of dots and see if it's a valid solution. And then I've got a few sounds hanging around, but really that's about it. And then there's the title screen, which I will show you. Here's the title screen. I just used the canvas object with a few images. And here's the dialog is also a canvas. So that's how I structured this project. I also want to show you what I would call the minimum viable build. And I recorded this about a week and a half ago. So let's jump into that. Hello, this is Alex from the past. I'd like to give you a quick look at the minimal viable build of my life as a teenage Pythagorean. So let's start it up. This is the level select screen. Each level has a completed state, a playable state, and a locked state. So at the beginning of the game, the first level is playable, all the other levels are locked. When you start a level, you are presented with an opening dialogue from Pythagoras himself. You can read this if you would like. So this first level, you just arrange these dots into a triangle. I'm doing this with my finger because my laptop has a touch screen. I'm not sure if this game will be web only or also available on Android devices. I'm not sure at this point. So this is an incorrect solution. If I hit submit right now, nothing happens. If I put that there, this is now the correct solution. So if I hit submit, I get some closing dialog. And as you can see that after the closing dialog, we go back to the level select screen, and now the first level is complete. The second level is now playable, and all the other levels are still locked. So if we start level 2, we get another opening dialog from Pythagoras. This one is much shorter, and it's trying to show us how to take 2 triangle numbers and make 1 square number. So let's go ahead and do that. There's a notable bug right now where if I attempt to place a dot on top of another dot, it can't go there, so instead it goes to the right. However, like if I had tried to place a dot immediately above where I just placed that dot, instead it would go over there. You see how it jumped. In the final version of the game, I would prefer if it found the nearest available spot. So that's the correct solution. Let's go ahead and submit. We get another ending from Pythagoras, and we unlock the next level. So as you can see, this is pretty straightforward how this goes. So far I've implemented the first 4 levels, but I do have a general structure for implementing levels now. So the bulk of the programming is completed. It's just level design and dialogue writing at this point. All right, let's take a quick look at how I structured the code. This is there are 4 main scripts. There's a level handler, which is the sort of the backbone of the whole game, which launches levels and handles the win condition checking, dialogue display, and what is being displayed at any given time. There is the level updater, which all it does really is it has 2 functions, and it just calls the relative function on the individual button. So if we look at the individual button script, level select button, it has 3 different sprites. So there's the playable sprite, the locked sprite, and the completed sprite. And unlock level, complete level, which is what level updater calls, are just setting the sprites, and if it was locked and you're unlocking it, set lock to false. And then if you click on the button, it will start the level if it is not locked and do nothing if it is locked. So this script is very simple. Let's take a look at this dot handler script before we look at the main level handler script. The dot handler script takes care of all of the dots that are currently in play. It has quite a few functions, but most of them are very simple. You start by just initializing some variables. There's a play, which is just setting a private variable. Stop is just setting the same private variable. This place dots function takes in dots from the definition of the level in level handler and places them onto the screen, adds them to this array called dots, and puts their positions in the dot positions array. I could have just used the built-in Unity positions, but I thought it would be easier to deal with them as vector 2s rather than as transform positions. Remove dots is very simple. It just goes through every dot and removes the game object, so that the next time a level is loaded, a entirely new set of dots will be placed. Get dot positions is just another getter function. And then the main thing here is this update function, which is just looking for if you click the mouse and you are hovering over a dot and you are not holding a dot, you pick up that dot, which makes sense. If you click the mouse and you are holding a dot, drop that dot and register its new position into the dot positions array. If you are holding a dot but you are not currently clicking the mouse, then it will automatically update the position of the dot to the nearest available spot. And as you can see, here is why it just goes to the right. I need to replace this xpos++ with something that finds the nearest available spot rather than just the available spot to the right. Finally, let's take a look at the bulk of the program here in level handler. So there's a lot of private variables here. There's a constant number of levels. I have it set to 15. I don't know if that will end up being the final level count, but thankfully if I change this constant, it shouldn't be a problem. I have an enum of states. So there's the play state, the opening state, the closing state, and the level select state. Whenever I'm making a game, I think it's very useful to think of that game in terms of what are the states. Eventually, probably I will add a title screen or maybe a credits state. I think it's a little bit jarring to throw the player directly into level select, but I have not gotten to that yet. These are some game objects that are in the scene that are useful to have references to. But the meat of the program is really down here. There are 4 initialization functions which get called here in start to initialize the opening dialog, the dot positions, the win conditions, and the closing dialog. And each of these are by level. So each of these are arrays, sometimes 3-dimensional arrays, sometimes 2-dimensional arrays. With the first index of all of these arrays is the level that the data is referencing. So let's look at that. I originally was thinking about reading in this data from something like a JSON, some kind of TXT file that's just for keeping data like this, but I decided it was easier for me personally to do it this way. So as we can see, the win conditions are just 3-dimensional arrays of chars. The first index is the level, the second index is the row, and the third index is the column. And so we're just looking for this shape somewhere in the play area, with the dots where the O's are, and the X's are just so that these arrays are a square. probably didn't need that, but if say I wanted to have this triangle be the other way, with the x's down here, it would have made more of a difference. With this shape of triangle, I could have had a ragged array, and it would have been fine. Next, let's look at the initializing the dot positions. So this is where the dots start in the level. On level 1, it's just a horizontal line of 10 dots. On level 2, it's the 2 triangles. So these are just hard-coded positions in the play area where the dots spawn, and obviously for every vector 2 position, a different dot will be spawned. So it also determines how many dots are in each level. And so there's 15 of these because there's 15 levels, but not all of them are meaningfully set. This is the closing dialog. We want the opening dialog next. So as you can see, this is what we saw at the very beginning of the first level. Pythagoras introduces you and gives you a task. So this is where you get your goal. This is how you know what the correct solution should be. And the closing dialog is just some kind of like, good job, congratulations, that's good work, followed by some sort of historical nod or fun fact about these particular problems. So that does it for all of the initialization. All the levels are just hard-coded in this format, which allows us to structure the code in such a way that if I wanted to add a new level, all I would have to do, increase max levels by 1, add the data to each corresponding array with something meaningful for that level. So anything that has to do with starting with some arrangement of dots and ending with some arrangement of dots could be a level under this system, as long as it was defined in the dot positions and win condition arrays. Start opening speech, start closing speech, start level, and end level are just state switching, so we can open those up. They all look pretty much the same. They're just setting up the objects in the play area based on what should be active and what shouldn't be active, and then setting the state. So this sets the state to opening, this sets the state to closing, and it makes sure all of the things are where they should be if the state was to be that. So these are all pretty simple. CheckAnswer is a little bit complicated, but really all it's doing is for every dot in the play area, it's checking if it can find the appropriate shape using that dot as the upper left corner. This does mean that when you're defining levels, there has to be, if you drew a square around the correct solution, there would need to be a dot in the upper left. That's usually the case, but I can see situations where that wouldn't be the case, and this code would not work for that. I'm not going to get into too much detail about this code, so I'm just going to move right along to update. And update just does different things depending on what the current state is. So if the state is level select, it doesn't actually need to do anything because all of that is handled by the individual level select buttons, which call a function in level handler. If it's the opening state, all it needs to do is start with the first dialog, change the text in the text box every time you click, and then if the dialog being displayed is the final dialog and you click on it, then start the level. In the closing state, it's pretty much exactly the same, except you're using the closing dialog instead of the opening dialog. One weird thing about this code is that when you enter the ending dialog, there isn't a direct click being registered that frame. However, when you're entering the opening dialog, there is a click registered that frame. So they handle that slightly differently, just to make sure that you always get to see the very first piece of dialogue in the opening and closing dialogue sections. And then finally the play state. And then finally the play state is just looking for, if you click the mouse and you are hovering over the submit button, it checks if your answer is correct. If it is correct, it starts the closing dialog, which ends the level. Otherwise, I'm probably going to just play a sound here. I'm not really sure what a good lose state would be at this point in development, but I figure for now, doing nothing is viable. So that's it for the first alpha build of my life as a teenage Pythagorean. Honestly, I don't even know if that is the final title at this point. All right, so you get the idea, and that also gives you an idea of the code. The final code is really not much different. There's maybe a couple extra things. A couple things got moved around. There were some bugs with the answer checking, and I also updated the answer checking to work with multiple shapes, so it's not just checking for one shape, it can check for multiple shapes. The dot handler, pretty much the same, except I made it so the dot that you're holding is a different color, as well as added sounds throughout these scripts. But the general structure is pretty much the same as that, which has been very nice. It's allowed me to focus on art and sound. And yeah, that's about it. That's how this game was made. If I update the game at all, I'll release a footnote and tell you guys how I've altered it.